Bonjour, good afternoon everybody. I want to welcome you to the first session of the day, which is on the topic of next generation 112 deployments. We have great guests here, international guests, even intercontinental guests, and I would like to introduce them to you. So first of all, we have Budge Currier here. He's the 911 branch manager at the California's Governor's Office of Emergency Services. Then we have Sorin Vasilca, who's the first Deputy Director of the Special Telecommunications Services in Romania. We have from Austria, Jürgen Schwanzer. He's from the Austrian Ministry of Interior. And Gabriel Unterholzer from the non-profit organization DEC 112. My name is Michael Pröstler. I'm a technical vice chair at EENA and also the CEO of GridGears. So before we're going to kick this off with Budge here, please give them a warm welcome applause. So Budge, the stage is yours.
All right. Good afternoon, everybody. So I'm going to go through a few slides to give you an overview of some of the work that's going on in California. And I just want to make sure you realize that behind me, as I manage the 911, what we call 911 in the United States, the 112 system in California, there's a team of 30 on my team that work for the state of California that are doing the management, engineering, and oversight of this system. And then we're working with a number of vendor partners, obviously. So the information I bring today is the result of all of that collaboration. So I'm going to talk about what we're doing right now, give you a quick overview of the system that we're deploying and have deployed, talk about connecting multiple 112 systems together, go into a little bit of detail on the standard and the role of that standard, some of the challenges and benefits we've seen, and then once you get one of these 112 systems and an ESI net up and running, what can you then do with it? I'll finish with that just to kind of get you thinking about the possibilities out there. To give you an idea how large California is in terms of 911 call volume, in 2021, we had 27 million 911 calls. Majority of them, 85%, came from cellular devices. We do have text to 911, or text to 112 for you all, deployed statewide, but you see the numbers there are relatively low compared to the rest of the statistics. What we train in the U.S. is call if you can, text if you can't. So the majority of folks are still using calling 911 or calling 112 as their primary means. I want to give you a sense of how large the system is that we've built out in California. You see California population is just under 40 million, about 424,000 square kilometers. We have 449 PSAPs, and 100% of those are accepting wireless calls. There's some differences in the U.S. where some PSAPs are not accepting wireless. We're accepting wireless. We manage and procure and install all of the equipment that does all of the call routing, all of the call processing equipment, and we have statutory authority. In other words, it's in California state law that we have the ability to do that. And that's different than a lot of the ways that some of our other states are organized, where they're called home rule, where local agencies have a lot more autonomy. We broke our system up into 4 providers. One of those providers is connected to every single PSAP in the state, and then we broke the rest up into 4 regions. The reason we did that is to make sure we could have redundancy between the two and to break the state up into what is smaller systems, so it's more comparable in size to the rest of the U.S. We have over 4,000 endpoints in our network. The entire network is built on IPv6 using SD-WAN. What we didn't realize when we started is we are one of the largest IPv6 deployments in the world for any technology. And I really thought they were making that up, and so I had to fact check that. And sure enough, we're all IPv6, and with this number of endpoints, the challenges that led to for us is finding equipment and network engineers and others that understand this kind of complex environment is pretty challenging. We've implemented PKI, or private key infrastructure, throughout the entire network, meaning you have to have a credential in order to pass traffic on the network. We manage the credentialing authority in California, and we conform to the Neenah model for that. So, as I said, we broke our state up into pieces. This is just giving you a visual representation of how we broke the state up. One vendor is connected to every single PSAP in the state, and they manage all the interfaces, they manage GIS, they're managing the LDB, and then they share that information with each of our regions. It's not a prime contract, subcontractor type relationship. We have individual contracts with each of the providers. We just needed somebody to make sure that they could step up and kind of control that standards perspective under the guidance of Cal OES, the organization that I work for. So we built this network out, we built a lab, and we tested all of the interfaces. Common interfaces needed to ingress the call from our carriers, the ability to fail over those aggregation points from one provider to another, and the ability so that no matter where the call lands in California, that system could fail over to another provider and still arrive at the PSAP and not break what's called the loss protocol. In other words, every one of our providers will make the same routing decision regardless of who receives the call and when the call is transferred to them. So as I thought about the complexity of the system we built, I wanted to provide some information on how ESI nets can be connected together. We face this when we connect to our neighboring states of Oregon, Nevada, and Arizona, and each of you will probably face this as you connect to either regional systems or other countries. What I've listed on here are some of the basic functions that you have to think through from a connectivity perspective. So those basic functions are the top 7 that you see there. BGP pairing, or Border Gateway Protocol pairing, you're going to have to figure that out. If you're using a private key infrastructure, you need someone to validate that key infrastructure in order to validate that you're passing that traffic on to somebody who's allowed to receive that. You're going to need to share the policy store. The policy store is what determines what happens to the call in various failure scenarios, or when potentially a PSAP is busy or the call has rang there and no one's answered it. What do you do in those conditions? The location database is where all the entries are stored to route calls. You'll need to find a way to share that data from one region to another. And remembering that when the call comes into this kind of environment, it's a SIP session, and once the SIP session is anchored, you can't transfer that anchoring. So when you build an environment where you're transferring from one ESI net to another, you got to account for the fact that it still remains anchored in that original ESI net that received the call. So you have to accommodate that. And then you have to figure out the interaction between the next-gen core services and how you connect them together. That would be the basic level functionality that you have to solve in order to support ESI net to ESI net connections. Now, we've gone one step further, and on the bottom, for true redundancy, meaning that you are able to deliver the call between every single vendor that is working on your solution. In my case, I've got 4 regions and a statewide. We have to do a little bit more work to make sure that that call can be connected to every PSAP. And that's the ESI net has to be connected to every single PSAP. That's the biggest difference. And then you have to go through all the failover testing and scenarios. We built a lab in California where we actually tested all these capabilities. And on the next couple of graphics, I'm going to talk about some of the things we went through to test. So we have the Neenah I3 Standard, which is good news. It kind of level sets the playing field, provides the technical requirements that all the vendors are supposed to be building toward in order to get us to interoperability where we all want to be. Now, what we did was we included that requirement in our contract, and that has been a huge benefit to us, because if you're managing separate contracts, that's the linkage between the contracts. Each vendor is held to the same standard. It also helps provide a baseline so that everybody is building to the same basic level of functionality. And what we've learned, at least in the U.S. with our systems, is that not everybody's at the same place. So we are able to work with our next-gen core vendors, figure out the differences that they have in their system. Not differences from the standard, but where the standard has a choice. They may have implemented it one way or another, and they've never had the opportunity to test it in a field environment. Our call processing equipment that's receiving these 112 calls in the U.S. has never really interacted with a fully compliant I3 network using PIDF and everything that is involved in that call flow. So we've learned a lot of lessons there, and so you're going to want to not make the assumption that everybody is built to the same standard in the same exact way at the same capability. So the example I use is, and maybe this will be too U.S.-based for you to understand, but we built a freeway. It's called Next Gen 911. And prior to building that freeway, we bought vehicles to run on that freeway, our call processing equipment. And they were supposed to be compliant with the standard. But once we got the freeway built and we took those cars up on the freeway, we realized that they were really Model Ts, and they could only go about 20 miles an hour, and they certainly could get down the freeway, but not with all the capability that we really expected them to have. And that's kind of where we are in our process. So when you're building these systems out, some things that we saw were challenges. The connecting together multiple autonomous systems using BGP is not easy. It is going to require a tremendous amount of work to make sure that your network engineers understand what's going on, because routing in this environment is very complex, especially when you're taking into consideration all the failover scenarios. IP version 6 is new. Not a lot of folks are working in that space, at least in the U.S. And the companies that build that equipment may not be used to filling orders. Like when I order something, it's 1,000 of something, and that's a big number for most companies to fill. TLS, which is needed for private key infrastructure, is something that can be challenging. You're going to need a unique IP address at your PSAP, and if you're in an environment where your PSAPs are sort of islands, they may be using private address space instead of public address space, meaning they're borrowing IP addresses around. And there's different ways in the standard to do things. You'll have to talk to those vendors that you're working with to make sure that they've chosen the same method. The example I've got here is you can either answer all calls at a bridge or do an ad hoc call answering method, and either one would be compliant with the standard. But if one chose one method and another chose another, they're not going to talk to one another. The location database and getting address points, road center lines, and the geospatial boundaries for all your PSAPs is going to take some work and effort. Don't underestimate that. And many of the vendors have not had the advantage of testing everything in the standard in a live environment or in a lab environment. So really consider how you're going to do that in your deployment case, or leverage some of the folks that you hear that are farther along in the process. So I talked about our system in California. Essentially, we've built out, from a PSAP's perspective, 2 different ESI nets. Everything is completely redundant. What I'm trying to show in this graphic is how aggregation fails over one to another, and the fact that we built multiple connections into the PSAP in order to drive up the availability. We have 2 fixed fiber connections. We have a LTE multi-SIM deployment, and then on top of that, for one of our vendors, we're using our statewide microwave network to connect that in. All of that is repeated with each vendor, so that we end up having, give you some stats. In our legacy system, we see about anywhere from 20 to 30,000 minutes of outage per month today in California. That's our legacy system. It's circuit-based, it's analog, it's single point of failure. We've had this network up at 250 PSAPs since November, 0 seconds of outage. That's the difference. So quite a bit of difference, and this is how we built it. Now, when we built this CSI net, obviously next-gen core services and routing of 911 calls runs across this network. But what else can you do? How can you leverage this network to do other things? So we know the immediate benefits you hear a lot about: voice communications, routing to any PSAP, improved location, improved reliability. We're seeing all those things. But it also gives you the opportunity to integrate other data. On down the course of the development, eventually in the U.S., we'll get video and we'll get photos and everything coming into the front end of the system. But how can we use this to integrate other data between CPE, data between CAD, CAD to CAD, those kind of things. We know there's limitations with some of the over-the-top solutions because they're not in the call flow, but how could that data also be integrated into an ESINet to be delivered to the PSAP? And we realized that integrating this, you don't want to integrate and bring extra data that causes extra work for the PSAP. Another screen, another this, another thing to look at. So this is just a graphic to show what's available today. And pretty much what we're seeing is that data sources come independent of the system, get pushed to CPE and CAD. If they're not intelligent to ingest that data, then you need a browser. And there's limited capability to share some of that information back. And the goal here is to take a look at this network we built. What else could we do with it? So we're in the process right now of soliciting vendors to build what we call a data sharing system. This system would connect together multiple PSAPs, build a cloud. Think of this kind of like a data lake. There's a portal that could be used to view that data that's in the data lake if your PSAP doesn't have access to integrate it into their equipment. And then we provide a conveyance model that gives you the ability to share between PSAPs. We could bring in information from the 112 system, from our cloud CPE, or any other supplemental data source out there, and the system will give the ability not only to share the information based on permissions, but to modify the information and also view the information. So hopefully you have some questions for me, and thank you for your attention.
Thank you, Budge, for the very interesting presentation. I think there's a lot of value for us here as well because, as you know, we might have the same issues and problems as you guys do, maybe on a geographical different level, not on a state level, but at least when we interconnect different European countries. So we have a couple of minutes for questions. Any questions from the audience?
Who are you using to provide next-gen core services?
Yeah, so we have 4 different vendors that we're using, and all of the contracts, vendor names, and all the details are linked on our website, caloes.ca.gov/911, and you can pull up all that. Or hit me an email, and I can give you the detailed info.
Thank you very much.
I think there was a question next. Yeah.
Hello, Stuart Walsh from Creativity Software. What level of accuracy are you achieving in your location database for the calls?
Yeah, so this will probably seem a kind of a scary statistic. We use, for call routing today in the U.S., we use Alley information and a master street address guide that has an address range. The accuracy of that is not very good. When we built the address points and we do the CDLXF validation and validate call routing algorithms based on that, our goal is to get 85% or better accuracy on the data from an LVF validation perspective. And the challenge there is that in our system, address point, road center line, and geospatial boundaries for our PSAPs have never existed, never been used. And some states are waiting until they get to 99% or 100% or 95%. We realize I pay $20 million a year today for my location information that's not very good. I want to get off that system onto the new and then build accuracy into it. Now, once the call is received and a record is found or location is delivered for that call, in the case of wireless, the routing accuracy is 100%. It gets exactly where it's supposed to be every single time. But we have default routing mechanisms in the solution in the event that the call comes in and you can't figure out where to route it. We've identified default PSAPs in each of our regions to route the call to, and then they would just receive the call and do a transfer.
Perfect. Any more questions? I think maybe one really short one. No? Okay, perfect. Thank you, Budge, again. So we're moving on to Sorin Vasilca, who will give us an update on the NG112 deployment in Romania.
Good afternoon, distinguished audience. My name is Sorin Vasilca. I'll be presenting the status of the implementation of next generation 112 system in Romania. First of all, I'd like to begin with addressing our thanks to EENA for giving us this possibility, especially to Christina and Freddie, for giving us the chance to present the progress of implementation of next generation 112. In the agenda of the presentation, I will briefly present to you who we are, what we provide in 112, some words about the existing enhanced 112 system, the central part of the presentation about the project, the contract, the implementation plan, the Gantt diagram, about the new project, the new generation 112, and in the last part of the presentation, some personal proposal or ideas to improve the operation of 112 in Europe. You may know that the STS, it is a state authority that runs its business on the financial budgetary funding, and we provide ICT services, secured one, for Romanian authorities. We deliver services of voice, data, video conferences, video streamings, and fixed networks, ad hoc one, and in mobility. We are the operator also for the Tetra system for narrowband, and we are the Romanian MVNO for broadband communication for public safety. In terms of 112 system, we have two main attributions. One is related with the technical administrator, being the technical administrator of the system, of the network. We keep the services alive, up and running. And the second one, we have our own personnel, employees, operating in the primary PSAP. The current system, it is county-oriented. Romania is split administratively in 41 counties. Each one has the same or similar version of the software and hardware since 2004, and the calls, incoming calls, are routed based on the administrative boundaries of the counties. In time, we added new features as SMS at 113 for persons with disabilities. We added voice over Wi-Fi. We developed our own call 112 application. We installed the features of AML and improved the localization. And of course, the eCall is operational. In this graph, you could see that since 2004, we received more than 300 million calls, both emergency, real emergency, and non-emergency calls. And if we sum up the billions of seconds, we could transform the disaggregated time in 262 years of continuous operation and traffic into the system. You could see, you could observe in the graphs, in the chart, that actually the two bars intersect or are equal in percent after 16 years of operation. It is a big lesson to be learned by the STS. It's not only about technical expertise when we are going to launch new services at the national level, but it's also very important to have in parallel, synchronized a public campaign for the people to be aware of the scope and role of the system. You could see that emergencies are distributed, and some large percent for medical emergency services, about 25% for police, 11% for firefighters. And on the map of Romania, you could see the limitation of this architecture, county-based. We have disparities in terms of traffic, of incoming call, that makes difficult the process of staffing the call centers to keep as equal as we can the service level agreement and the quality of service all over Romania. And the second limitation, big limitation, you could observe it in the graph, in the blue one. Yeah, we cannot even foresee some spare parts position and some complementary operational shifts to supplement the existing PSAP for events with a very fast evolution, like the one represented here in Bucharest 26, I think, January 2019. A phenomenon, extreme weather condition of freezing rain with falling trees and breaking electrical lines. You could see how we cannot cope with a sharp increase of the traffic. And from 2-3 seconds, that is the average for answering time in the PSAP, we registered hundreds of seconds. So for these reasons, and also for the fact that we used in enhanced 112 system the technologies of 2000 with end of cell, end of support equipment, and not only for that, but to accommodate new features and modern services of the 112 according to the specifications of next generation 112. We established in 2017 two major strategic objectives. One, to increase the quality of service, and at the same time, to lower the OPEX. And the idea was to change the architecture of the system, to eradicate the limitations and the malfunctions, the anomalies we faced in the existing system by having in mind from the design stage security, high availability, with disaster recovery and business continuity, and our documentation and design, to get a low response time and to have and to route the incoming call to the PSAP that has available resources in such a way to deal with the traffic that could increase in events of man-made or natural extreme weather condition as presented before. In terms of lowering the operational expenditure, we reduced the number of PSAPs from 41 to 3, and actually from the counties, the operators and dispatcher connect remotely to these 3 national PSAPs that work in mode of primary, backup, and contingency. We use also the virtual infrastructure, and we reduce the OPEX by having 0 application installed in the operator, by calling to the function of web RTC and web browser to get into the system for the call takers, and also virtual desktop interface. So there is no need in cases of failures to get to the dispatch site. We started with to write down the feasibility study, the technical project, and then for each component, the technical specification. In the bottom side, you see the elements of physical infrastructure, and the upper side, you see the CAD, list, GIS, PMIA, automatic resource location, and what is specific for next generation 112 system. It's good to mention that after this, we prepared this documentation, we presented to the government for allocation approval for funding. That happened on the August 2018, when the government of Romania approved 47 million euro for this replacement or refresh or completely replacement of the existing 112 with a new one. And it took 1 year, and we signed the contract having a competitive tender procedure. So if you like to take into consideration the implementation of next generation 112, it's good to take into calculation of 1 year of preparation of the documents for competitive procedure, then maybe 1 year. It depends on the legal framework in your country for the procedures, and then to sign and implement in the next 3 years. So I would say that for such an important critical system, you could take into consideration of maybe 4 to 5 years. The contract has two major phases. In the first one, we like to see up and running all the features of the NG112 using some counties, pilot, Workstation and dispatcher. We'll have a partial acceptance test, and then in the second closing, we actually roll out the installation of the new system in all the country, in the dispatch position and the sub and the workstations of the operators. In this nice diagram, you could see in the left that we replace the E1 lines with SIP trunks, and in left side we have the people that generate incoming call by RTT, video, data, PMA, transmitting over, encapsulating into the SIP trunk the information specified in NG112. On the right side, it is let's say the back end where there are the agency, the firefighters, the fire brigade, the medical unit for extrication and resuscitation. And in the middle is actually the new infrastructure with 3 national centers and vertical crossbar suggests that each service is replicated. That increased the availability of the service. So you could see the interfaces in green, the ingress, the egress from the EasyNet. One important part is the ESB, where we connect the third-party server to the NG112. For instance, through this interface, we connect natively the Tetra system, and from the dispatch position, by giving a click, they could set up the group communication on the field resources by using Tetra. The operator workstation and the dispatch workstation has 3 screens. On the left side, you could see the file case with the field with the data, and in the middle, it is for call control. And then the right side, it is the geographical representation, location, and the field resources, quite moving in real time on the screen. If for many reasons, no browser, neither the browser nor the VDI is working, the operator has a traditional and conventional way to pick up the calls by using a hardware phone and to dispatch the resources by using the radio station. If we look at the time being, I would say that we are in the full process now of testing the applications. Everything is installed in terms of the equipment, including the application. We are testing and making correction. Actually, the contractor is making the correction to the software and patches the software. And for the next stage, for the next months, until the end of the year, we'll have testing, continue the testing, correction, partial acceptance test, and a lot of training. As Dimitrios said in the morning, training, both for the operator and dispatcher, and also for technical staff. And in the last few slides, I like to share to you my opinion on how to improve the operation of 112. On the left side, we have the map of Romania with the boundaries of the counties, where, and in red, it is represented the overlaps of the coverage, of the mobile coverage. And the length of these lines is about 10,000 kilometers. We registered till now 1 million of incoming calls that under this red service area goes to a different than the one intended. So it is about redirecting because of the signal strength to a neighbor county. Now, if we make a comparison with the internal board of the EU, the calculus from GIS system, it gives to us 83,500 kilometers. And if we do not give up to the way of operating by using international numbering planning in between the SAP, probably a large number of the calls will get into the neighbor country. And my proposal is to approach a network of NG112 networks all over Europe to define local domains and to transfer full set of data, metadata, and the voice of the callers in cases that by roaming, one user gets into a different sub. My second proposal is to define an uniform and unique level of ambition in EU. So let's analyze what is the level of ambition to have figures, committed figures and guaranteed figures for the citizen that once they call the 112, they get support from the state authorities. In the matrix, you could see large differences for transportation of the patient from the incident place to the hospitals. And if we replace the counties of Romania with countries of Europe, my question is, would you like, in cases of emergency, to be in the country in the top left side or at the bottom right side? In Romania today, we could have 10 to 30 minutes for this transportation of the patient. We talked about in the last conference about the common interface. And I give to you this example of symbols. Symbology from the military field, from the command and control center tactical station. Maybe it's time to define the standard interfaces for the operator, not only in terms of position of the fields and the symbology, but also about the wording, about the interview, to have common procedures all over the SAPs in such a way to back up each other in cases of one SAP is flooding, to have supplementary SAPs from different countries, or to have even one SAP backup in using the same language. Here is the location accuracy and the technology used in the system. What we propose to you is to analyze the possibility to approach in a similar way with the FCC obligation for the public operator in long run, in 10, 15 years, to provide accuracy in, let's say, 95% of the cases with some few meters error, because having good accuracy in localization discourage the criminal acts and also discourage for faked or malicious calls that add no value into the 112 system. Ladies and gentlemen, I like to say that each orchestra has a conductor. To me, the conductor on 112 in Europe is EENA. And my proposal to you is to analyze and decide if you could re-engineer EENA by adding new line of business, new divisions that to care about the EUSLA, about operator certification programs, about the testing laboratory centers under the aegis of EENA, to set up rules and obligation and to empower EENA with this power of making obligation to fit into level of QoS and SLA. And also, the important is the strategic business analysis, division or direction. You all know that in Barcelona, some operators declared that they will switch off 2G and 3G services. And on the other hand, all of the voice call transferred to the 112 are over these technologies now. So it's good to have an EENA, one division, to look and to make the management or to assess the risk management and to have a strategic business analysis to avoid any strategic surprise. Thank you very much for your attention. I'm open to your question, and please feel free to contact me afterwards.
Thank you, Sorin. We're running a little bit late in time. If maybe we have a short question somewhere in the audience. Otherwise, I think that Sorin will be very happy to answer your questions after the session. Okay, perfect. Then we move on to the presentation from Austria. It's a shared presentation between Jürgen Schwanzer and Gabriel Unterholzer. The stage is yours.
Thank you. Good afternoon also from my side. The title of the third and the last pitch in this session is Emergency Apps in NG112 environment. And I'd like to approach, when I need it. Thank you. To approach from an organizational point of view and to give you a follow-up on my presentation held in Riga last October about the Austrian situation and the developments there. I just want to give a very short summary on this to keep all of you quite on the same information. So the background in Austria is that we have a very heterogeneous emergency landscape. We face also national emergency numbers as well as different areas of responsibilities, as we have 9 provinces. We are in charge, the Federal Ministry of Interior, for 112 calls, e-calls, and the national emergency number to the police. And we faced an harmonization of our PSAP structure, and we also implemented one central system that brought us in the situation and the position to step further with some developments. We count on European standards, as mentioned already in this. And we decided not to bring all the purposes and possibilities of NG functionalities to a decision, but to start with one well-defined and clear bordered approach, to start with a text-based, digital text-based emergency call and further step-by-step developments. So what has happened since the last EENA conference in October? The duration is quite short, but anyway, the announced new Telecommunication Act got in force with November 2021, and therefore we are now obliged as Ministry of Interior to operate the core services. We signed a contract with the current operator of this core services. It's a non-profit organization and association called TEC 112, with 2 main purposes: to ensure the service until we will have set up of our own, And the second very important part is a development partnership for the further innovation to learn from each other. And for the sake of completeness, because it was mentioned in my presentation in Riga, we also changed our central receiving point from the PSAP in Vienna to the PSAP in Burgenland, in its capital Eisenstadt. Who knows it? It's a very small country, small town. And the reason is quite obviously it was an organizational decision because of the available resources there. What else happened and led us to implementation also of a new feature? Basically, we have had already good cooperation with the dev community, and we had also several text-based emergency calls, and that led also to a positive echo in the media about NG112, and as showed here, a deaf woman, I guess she was from Poland, but anyway, this is not decisive, was stuck in a wooden crate and could be saved out of her emergency situation. And we also enlarged our cooperation with the public, because we also faced in Austria in the last years a very unwanted development in femicides. And so we implemented a silent emergency call, and follow the aim that women that are confronted with an acute domestic violence should use this silent emergency call. And we also got already some or several of these silent calls, and we could help them in this situation. So this was a short summary and introduction from the organizational point of view, and I'm very happy about handing over now to our implementation partner who has the expertise how this works and how this step-by-step development is not rocket science and no big deal. So Gabriel, the stage is yours.
Thank you, Jürgen. I will already use the silent emergency call for explaining how you can integrate applications, smartphone applications into into NG112. DEC112, that's us. So I will start with a typical NG112 infrastructure. On the left-hand side, you can see several different apps that are integrated. You have the ESINet with known components and the PSAPs that are connected to. And what NG112 does for you as an application developer is it routes your call correctly. If there is an emergency issued by an app, for example, you can be sure that the ESINet will route, based on the location, the call correctly to the correct PSAP. And this call routing is mostly non-trivial. Especially in Austria, we are very federated when it comes to emergency calls. So this is quite tricky. And the ESINet acts as a kind of black box for your application and takes a lot of complexity from your application, because the application itself does not have to think about call routing. This is done by the ESINet. And you have just one point of interconnection for your application to connect to the ESINet. What is very important in this case is app subscriber management. So if you have an emergency application, you should know who your users are, because this is also what the PSAP then in the end wants to know, who the person is who calls. This can be achieved in different ways. For example, for a mobile network operator, it's quite obvious they have SIM registration or existing subscriber management. For a smartphone application, For example, you could use an SMS verification that is maybe well known by apps like WhatsApp or Signal, that you receive an SMS token and therefore verify the telephone number. Yeah, I already want to go into the first variant. It's the SIP-based variant of integration into NG112. This, of course, gives you all the features, especially real-time media features in NG112. On the other hand, of course, pretty obvious, it requires SIP capabilities within your app, but this is not really a problem. We have already shown this with the app that we use in Austria. We have SIP capabilities directly within the application. There are SIP stacks for a great variety of platforms available, so you won't face any problems there. And what I want to specifically highlight is that as application developer, you can use SIP over WebSockets, which is usually available on all app platforms and also on the web. Yeah, and this is actually how we do it within the DEC 112 application. Which is, what is really cool, especially for smartphone apps, is that you can use very accurate location. You can use GPS and GLONASS information for normal apps, or if you are on the web, you can use geolocation APIs that are provided by the app to have very accurate caller location using for routing or call dispatching afterwards. On the image here, you can see an example how this direct integration via SIP can look like. The app directly interfaces with the SIP proxy, which is then connected to the ESINet. This is the path that is used for signaling and for creating the connection between the app and the PSAP. And of course, this can then be added, real-time media can then be added on top of this channel. So NG112 takes care that the call is correctly routed to the PSAP, and then the app can negotiate with the PSAP what kind of real-time communication channels should be used. In this case, for example, this could be WebRTC if it's a web-based application. The second variant that might not be that obvious in terms of NG112 is non-SIP-based applications. On the pros side, you have that this can be quite easy because you can choose the protocol you like. It is suitable for existing apps because you don't, in the best case, you don't even have to change your existing app, and is also suitable if resources are limited. So especially in IoT environments, the resources of the devices could be limited. On the other hand, of course, the feature set might be restricted, especially on IoT devices. Think about fire alarms that are integrated into a smart home, or like I have here a wrist button that can be clicked, which issues then an emergency call, especially for assisted living, for example, for elderly people. These devices, they have their own protocols and talk to an intermediary device like a smart home, and are managed by this. And this means not the devices directly issue the emergency call, but for example, the smart home issues the emergency call. It takes over in, for example, with the fire alarm. It receives regular temperature updates. If it reaches a certain threshold, then it issues an emergency call via NG112. What is, in this case, also particularly interesting is that the gateway usually knows where the devices are located. So, for example, for a fire alarm, it knows where it is installed, so it can inject the location and therefore allow for correct call routing. This kind of integration is also interesting for legacy technology. Think about SMS. While this might not be that popular anymore, especially amongst the young, it is very important, especially for accessibility reasons, because it is usually the only application that deaf users can use to issue emergency calls without having to install a separate app on their smartphone. So a different approach can be used here to transfer SMS into NG112 compatible calls. Now I've only talked about text-based emergency calls, and I know real-time media can be quite complex, so especially the infrastructure setup can be quite complex. And that's why I want to give you an idea how this could be also solved differently in an intermediary step. So you could use existing media channels or existing conferencing tools, for example. Remember, NG112 already cares that your application is connected to the correct PSAP. Why not reuse this channel and exchange, for example, a meeting URL to open MS Teams, Zoom, or Jitsi session? This can be integrated quite intelligently in your app, so the user does not even notice that communication is based on a cloud service, but takes a lot of complexity from your system. However, I want to emphasize this is most probably an intermediary step for NG112 deployments. In the end, of course, you may want to have direct real-time communication without having to integrate a cloud platform. What my personal take-home messages for you, NG112 takes for your applications the most difficult task for you. It tackles it, namely call routing. Remember, call routing can be very complex, and you don't want to have this in your application. And NG112 does not restrict your application in terms of communication channels. It's up to you as application developer if you want to integrate text, video calls, or integrate any IoT devices, whatever you want. And what we have experienced in Austria is that it's really good to start small. We started with a text-based messaging approach. It already requires a whole ESINet, but we've already learned so much by only using text-based emergency calls, so much information that was generated that we can use to improve the NG112 infrastructure, and the next steps are then, of course, to integrate voice over IP providers, mobile network operators, to have it not only for text, but also for audio calls. Now I've given you some insights how app integration could be accomplished. There are some examples, what we've already tried out in Austria and what has proven to work well. And if you still don't believe me that apps can be easily integrated into NG112, there is a telephone number and a QR code you can use to send text messages via Signal. This Signal app is most probably known to everybody. In our NG112 test system, you can chat with our test bot there. This should be a proof that application integration with NG112 is simple. Thank you.
Thank you, Jürgen. Thank you, Gabriel, for this update on the status of NG112 in Austria, especially on the use cases. Do we have any questions from the audience? Don't be shy. There's one.
Thank you. Philippe Dacol from Belgium, from Astrid. I have a question for the previous speaker. If I could see from his slide, there is a lot of bodies of organizations he's taking care of, and I think it's all centered over a governmental structure. Now, my question is basically twofold. First of all, if you're responsible for all these individual different organizations, how can you manage to make sure that there is a common understanding of about the technology that needs to be used? That's first. And secondly, I'm not too sure if I understood it correctly, if it goes only on the technology, or if it goes up to having also the call takers in these 112 centers. And then, of course, is this a kind of neutral call taker, or is it also per discipline?
The question was to you again.
Was it a question to me or
No,
to
the
my previous speaker?
You are
Yeah?
together,
I guess
as the
it's
previous
yours.
speaker. Yeah.
Excuse me, sir, because of the echo, it is a very strong echo in here. So I couldn't follow you. Yes.
I can summarize it I can, maybe, I don't know if you can hear me better now. I have two questions. Do you also manage the call takers in your organizations, and are they neutral?
Yes, our system has two parts, the primary PSAPs, where the personnel of the STS operates, and the dispatchers. That belongs to Ministry of Health, Ministry of Interior, and actually we have the first interview of 30 seconds, for instance, 40 seconds, getting the information about the person, the case, the claim, and the location, and then we transfer it to the police department, for instance. So we are a state organization that does not belong to the Ministry of Interior.
Okay, okay. And then secondly, in terms of the equipment that you use in your call centers, how can you make sure that there is a common understanding of what technology needs to be used? How can you get everybody on board on the decisions that need to be taken in terms of technology?
Yes, if we speak about the existing system, we have Windows platforms and servers and Workstation that are end of sales, end of support. But in terms of the new NG112 system, there are equipment that are at the physical layer. The equipment is COTS. We have our own data center, and we have virtualization. For instance, we have 1,000 virtual machines running on 100 physical servers. We applied in the acquisition book all the standards and regulation existing for the NG112 devices, equipment, interfaces. And we are conducting now the testing according with these procedures. So if we speak about the standards products or services, we are in line with the next generation 112 system specifications, and we could easily replace one computer by having this WebRTC web browser to connect to the central center, sub-center.
Okay, thank you. As we're running out of time, we're going to close this session. So thank you, gentlemen, for a nice presentation, and warm welcome on the applause. Just some closing remarks regarding the next session. In this room, track number 1, we have the topic of public warning, moving beyond the technology mandate. In the parallel session in track 2, we have the topic using data to anticipate, predict, and to respond to emergencies.